We're surrounded by this invisible language every single day. It's the silent conversation between you and your technology. And it's what decides whether your phone feels like a part of you or just a frustrating piece of plastic. Today, we are decoding that language. We're diving into human-computer interaction, which, if you're an IB computer science student, is something you absolutely need to know. So let's just start with a really simple question. Think about your smartphone. The first time you picked it up, did you sit down and read a giant manual? Did you take a class on how to use it? No way, right? You just picked it up, you started swiping and tapping, and somehow you just knew what to do. How is that even possible? Well, that's the magic right there. It's because the absolute best design is totally invisible. It just gets out of the way and lets you do what you want to do. And that is the entire goal of human-computer interaction, or HCI. It's the art and science of making technology so natural, so intuitive, that you don't even have to think about using it. Now, this all starts with something physical, a principle called ergonomics. It's a simple but powerful idea. We should design things to fit people, not force people to change to fit the things. You ever notice how a good computer mouse just feels right in your hand? Or how the keys on a keyboard are perfectly spaced? That's ergonomics. It's about making sure the physical shape of our tech works for us, not against us. Okay, so that idea of fitting the tool to the person, that leads us to two really crucial concepts: usability and accessibility. Now, they might sound kind of the same, but for your exams and just for being a good designer, you have got to know the difference. So here's the breakdown. Usability is all about how easy and efficient a product is for the, let's say, typical user. Can they get their task done without pulling their hair out? But accessibility, that's a much bigger and more important question. It's about intentionally asking, how do we make sure that people with the widest possible range of abilities can use this thing? One's about ease of use, the other is about inclusion. It's a huge difference. But of course, let's be real, not every design is a masterpiece. So what happens when that intuitive, magical feeling is just gone, and all you're left with is confusion and frustration? Well, let's break down how to actually analyze a system's flaws like a pro. Before we get all formal about it, just take a second and think. What was the last app or website that made you want to just close the laptop and walk away? I mean, we've all been there, right? That feeling of, why isn't this working? That is the direct result of a usability problem. So to get past just being annoyed and into actually making a smart critique, we need a structure. And that's where a framework like this is so useful. It gives you the right words. So instead of just saying, this app is confusing, you can say, okay, its learnability is really low, meaning it's hard for new users. Or you could look at the number of errors it causes. It's a much more precise way to figure out exactly what's wrong. And when you start using that framework, you see the same old culprits pop up over and over again. You've got that fiddly, awkward hardware, or a super complex user interface that just tanks learnability. Or my favorite, when you need to already be an expert just to get started. These are the classic signs that the basic design principles were just ignored. A modern game controller is the perfect example. If you're a gamer, that thing is an extension of your body. It's incredibly efficient. But what happens if you hand that same controller to someone who's never seen one before? They're looking at 2 joysticks, a D-pad, 4 triggers, 4 face buttons. It is completely overwhelming. For that new user, the learnability is practically zero. It's a real usability nightmare. Okay, so we know how to spot the problems. Now for the really important part. How do we build better solutions from the ground up? This is where we make that big shift in focus, from just making things easy to use to making them usable by everyone. And that, right there, is the heart of accessibility. Now, to design for accessibility, we got to be precise with our language. And this distinction from the World Health Organization is key. An impairment is a loss of function, like vision loss, for example. But a disability, that's what happens when the world, or a piece of tech, creates a barrier for that person. See the difference? The goal of great accessible design is to remove those barriers, to make sure an impairment never has to become a disability online. And the amazing thing is, technology gives us some really powerful tools to do this. You've got specialized gear like Braille keyboards or the awesome Xbox Adaptive Controller. But here's what's truly fascinating. Think about things like voice recognition or text-to-speech. They were originally designed as accessibility tools. And now, millions of us use them every single day just for convenience. That's the power of accessible design. It almost always ends up making things better for everyone.
So, let's zoom out, way out, because creating technology isn't just about writing clean code or making a pretty interface. It is about understanding the impact your work has on the world, the good, the bad, and all the things you never expected. And being able to analyze that, that's an essential skill.
In fact, check this out. This is basically the IB examiners telling you the secret. When you see the word discuss on an exam, that is code. They don't want a book report. They want you to be a critic. They want you to look at an issue from all sides, the good, the bad, the pros, the cons. It's all about balanced, thoughtful analysis.
But how do you actually structure that kind of analysis? How do you make sure you don't miss anything? Well, here is an incredibly powerful framework you can use. It asks you to look at any technology through 5 different lenses: moral, ethical, social, economic, and environmental. It's a checklist to make sure you're building a truly comprehensive critique. This framework forces you to ask the really big questions. Let's go back to the smartphone. Morally, does it do more to help or harm? I mean, it connects us, but it also enables cyberbullying. Ethically, what choices were made about our data privacy? Socially, how has it completely changed how we interact? Economically, who's getting rich from it? And environmentally, what's the real cost of making and throwing away billions of these things? See, this is how you build a complete, nuanced analysis. And this brings us right to our final thought. Everything we've covered today, this isn't just theory you memorize for an exam. This is the ethical foundation for the technology that you, the next generation, are going to build. So the real question isn't just what will you create? It's who will you create it for? And how will you design it to empower, to include, and to truly benefit everyone?